Okay, hello. Welcome to Spherical Geometry. Ignore the German stuff here. Alright, you guys can write this if you want or try and figure it out. Hopefully it's sort of original, I just made these questions up. So find the time difference between Tokyo and Sydney. These are the actual coordinates. So Tokyo is in the northern hemisphere. This is the latitude. This is the longitude, and we're in the southern hemisphere. The longitude is pretty similar, not that much difference. So in fact, the longitude is the only thing that we care about, so the time difference. We're not worrying about time zones, so we're going to compare 151 and 140. They're both east, so just multiply, subtract. Okay, so 11 degrees. That's the angular distance. So then, in order to convert that to like a time, you just do 11 times 4. Each degree is worth 4 minutes, so 44 minutes. This is easier than I thought it would be. Okay, I can put that in red. Alright, if it's 12:22 on Saturday, I wrote that because that's what time I actually wrote this question. What time is it in Tokyo? Now, Sydney is further east compared to Tokyo. So that means we're in the future, man. So when it's this time, it's actually not even that time, it's 44 minutes earlier. So basically we'll do like 12:22 AM minus 44 minutes, whatever. Okay, so however you want to do it, I would just take away 22 minutes. That leaves 22 minutes still. That'll take us to midnight, and then 22 minutes before midnight. It'll be 11:38 PM on Friday. Okay, so 11:38 at night. Does that make sense? Hopefully. It doesn't need to be like that. That's the answer. Okay, so if you want to look at that, yeah, I don't think there's much else to say. Let's move on. The great circle distance between these 2 points. Now, what do you notice about them? So we've got this thing and this thing are the same. So that's the latitude. 0 degrees is special. It means it's right on the equator, right in the middle. And the great circle means, you can sort of draw circles around Earth. If it's a great circle if it goes the longest possible way, all the way around the Earth. Like if you did a little circle near the top of the Earth, that's not a great circle, it's just a small. So that's why it has to be either the equator, or it has to be a matching longitude. Anyway, so we're going to look at the difference between 138 and 77. Oh, it's present. Yay, hooray. Okay, so 138 minus 77. Okay, so that'll be 61, I think, degrees. Okay, so to convert that to a distance, remember the circumference of the Earth is 2 pi r, or any circle 2 times pi times the radius, about 6,400 kilometers. And then we're going to times that by this fraction, 61 out of 360. Okay, I'll use my fancy thing. I can't see. Okay, the first part's easy. Okay, times 61 over 360. Okay, 6,840. Just round it up to the nearest kilometer. Alright? So, if a plane's traveling... Come on, why is it so slow? If a plane's traveling this speed, how long will it take to travel that distance? You just need to divide. How many times does that go into that? That tells us how many hours. So remember, show you working. Divided by 180. Okay. 6814. Okay, so I get about 6.95 hours. What you should do is press your degree button. So I'm going to do it a different way. We can take away that 6 and just times the fraction part by 60. It's going to be 57 minutes. 6 hours, 57 minutes. Okay? That's it. Alright, I think there's only one more question I made. Find the great circle distance between these two places. Oh, okay, this time notice that I've made the longitude the same. So they're both north and south of each other. This one's 12 north, that's 35 south. So we need to find the distance. This time we actually add because they're opposites. So that's 47 degrees. Okay, that's the angular distance. Notice that there'll be no time difference because they're north and south of each other. So 47, okay, so same formula. Possibly we should write a D here. Maybe I should have written distance equals. Doesn't really matter. I don't care. Let's just do it. Times the radius times 47 out of 360. I have to think. 2 times pi times radius times 47 over 360. 5,250. Close enough. Kilometers. Alright, and that's it. So it's called Great Circle because it goes all the way around the Earth. Okay, just remember. If a plane travels at that fast, how long will it take? We just divide. Okay, and it should be a little bit more than 5 hours. Might be 6 hours or something. Okay, let's figure out what that equals. Over 915. So 5.73. Again, I'm going to do my trick, or whatever you want to call it. Yeah, that's it. Good work. 44. So 5 hours and 44 minutes. 5 hours 44. So if it left at 6 p.m. on Friday, when will it arrive? We don't need to do any time converting because of time zones. I was going to put a question in like that, but do that another time. Where is it? What is it doing? Okay. Okay, trying to stay calm here. Alright, so we're just gonna do, yeah. Basically, well, actually the answer is really easy. 6 p.m. plus 5 hours 44. So it'll just be 11. Why did I do it like that? 11:44 p.m. on Friday. Just later that night. Okay, nothing fancy about that. And that's it for now, I think. So hopefully that helps a bit with spherical geometry. Okay, see you later.